And I just about think that it's a complete one. I'd have to copy and paste it. This is from our notes last Thursday. I could start Visual Studio. I mean, it's not complete for the assignment, but it's a complete start to it. And it's the one that we would want to modify using switch and case for the next homework assignment, which I'm not sure I saw. Is the Dropbox for the shift case one missing? Yeah, sphere density, and so 8 should have been sphere density revised. It'll be due a week from today. And so it is just to modify it to use switch and case.
Modifying number 7.
That's correct. That's correct. That'll be what the homework assignment is. Come on. All right. Well, that looks pretty odd. I'm not sure why. I'm seeing something with precompiled headers. Oh, I must have opened one with a precompiled header and then made a new one without it. Okay, so here's the sphere density program that we were seeing on Wednesday. We get the metal. No, it's not. Is it? No, it's not. Yes.
Are you recording?
Yes, I am. So everybody's getting to see me fumbling around trying to get this ready. I'm so embarrassed. All right. So, and thank you for asking. I absolutely appreciate it.
I kind of can't
I
talk
think-
today, so that's why.
I think that might be it, because for the sphere density, the options are ice, aluminum, and gold. You got ice and aluminum right there.
Okay, so I was doing something funky here where I created a menu function which displayed the function. And so there needed to be a function called CIN-INT in order for that to work. And it would list off the different types. And it doesn't, so I'm going to change that, and I'm just going to put a C out here. Oh, it's already there. All right. And then so CIN into material.
Well, that CI statement above it doesn't have a semicolon. I think that might be breaking up the next one.
And I was missing a colon here, so I'm getting an error on the next one. All right. Okay. Pardon me, Simon. I didn't understand that.
No, I was just saying.
Oh, okay. Okay. Right.
Figure it out.
Okay. Okay. Same deal here. Oh, I know why. No. I don't know why we did that. Okay. All right. Now it's a working program from last week. And we could start changing it to shift and stuff like that. So can you have yours up? Demonstration.
This is what I've gotten so far. After my reset, because the last one, like I said, was too spaghetti. That's what I've gotten. I'm still working on it.
Oh, well, that's okay. And if we were going to turn this, one of the questions we had was, how do we handle it if, and that's what that thing that I just deleted was, how do we handle it if the user types in bad data? So for example, if we ran this, and I typed in something like that. Well, that's not bad. It's saying unknown material, defaulting density to 1. But then it went on to the next one and said unknown size, default of 1 will be used. It didn't give us a chance to type in the size because it was in an error state. So there's a couple ways you can fix that.
You can just use a pause statement, can't you?
No. Well, I mean, we could stick a pause here, but it's not going to. Well, let's see what happens. Let's do a system pause there. This is really not what we would want to be doing, and I'm going to show you a different way. System parentheses quote pause, but I'm curious as to whether it'll work. All right, so I'm going to type in garbage, press any key, and again, it didn't accept it. So the problem is that once you enter string data where it wants a number, it gets into an error state. And none of the input after that's going to work unless we clear the error and ignore the next piece of data coming into it. I'm going to get rid of that. And we could do that after every single call. I could do cin dot clear there and cin dot ignore and say, yeah. If there's anything waiting in the buffer up to 1,000 characters, which there won't be. And now the problem is going to go away. Whether it's going to work correctly or not, I don't know. But if I type in garbage there, ooh, neat. Not what I expected to see at all. All right, I need to go and see my cin int function that I had queued up inside my notes.
This is what happened to me the first time I did it. I just kept like hitting weird stopping points. I just ended up found myself in Stack Overflow and it was a mess with that.
And Simon, was it you and I who was working on getting it to ignore erroneous input? Okay.
Yep.
And so we cooked up a way of doing it. And I think we tacked it on to the very end of the notes here, which would confuse the people who were trying to then use this as a basis. And so what we do here is we can use a modification of the CIN syntax. And if it fails, then we can clear the error and we can ignore, okay, that's what I did wrong, is I forgot to put the second syntax here. And this syntax is going to look stupid. I'm sorry about that. But where I have, can we get rid of that? Can we stop running? Stop debugging? Where I have CIN arrow material, we can do this. If, and we can enclose that in parentheses, and we can say if that input failed, if not, then we have an error. And so I could see out error, bad input. And then I could default that the variable to 0 or something like that, or it would accept whatever the default value had already been set. And I don't think I had set a default value up here at the top. So then I could just set it equal to -1 or something like that. And you don't need to do it this way. I'm just demonstrating. Material is equal to -1. And then we need to clear CIN's input buffer. And we need to tell it to ignore the following characters that might be waiting in its input stream. Ignore 1,000 of them up until somebody types in the return key. And that should be a single quote. All right. Now it's going to work okay. But that sure is a lot of stuff to have to do every single time you read in a number. It's a pain to have to do that. It's a big pain if it doesn't even compile. Oh, bless you. Uninitialized local variable material used. So I am going to have to default material equal to some possible value. I'll just set it equal to 0. In that case, setting it to a different value when we get down here is not strictly necessary, but I'm going to go ahead and leave that line. And so I run it, just a sec. I'm going to prove this works. Ooh, it didn't work at all. It immediately said unknown material, default scene density to 1. Now why is that? I hadn't even...
Don't actually ask for CN.
Oh, CIN error in the material? That should have handled it though.
That should. Okay.
Yes, Shelley?
Is this like a program that you guys try to do based on the homework for this year?
This is the Sphere homework, and we were messing around with it based on questions
Okay.
that came up on Thursday.
Alright.
Some of them after class. So I was trying to recreate that work. Guess I'm gonna have to stop doing this because it worked beautifully for us on Thursday night and is not working now, and I don't want to waste y'all's time trying to figure out why. Yeah, working now. Did I do? No, I don't see that. I don't see the rookie error putting a semicolon after the end of my if. And now it's waiting. All right, now it's correct. Really gnarly syntax, gnarlier than I was even having to expect. But what this is doing is we have enclosed this inside a pair of parentheses, and that returns a value. If an error value returns, it's going to return a 0. If a non-error value returns out of it, then, well, it's a non-zero value. And so this would turn that 0, if it was an error value, into a true, which could trigger all of this. And so what we have here is that if they typed in some letters and we trigger the error state that was picked up by this, then we can display an error message. We could set our variable equal to a good value. We could then clear the error state, and then we could ignore out to a certain number of characters. That's just to wipe out any extra letters that happen to be typed in this into the input stream. Like, if I'd sat there and I typed in, 1,000 A's in a row before I hit enter, we would want to ignore them all. So what we could do, because that looks so dang ugly, is we could put that into a function instead. And I guess I want to start a new project and go ahead and do that as the first thing we do before we get any further. So I'm going to make a new project. I don't know what day we're on. Elemental PQ. Yeah, we're on Q, aren't we? Lecture Q. Go and get my boilerplate. add new item, lecture Q.cpp. So here's what I'm going to do. Instead of making it say hello world, I'm going to make it say, please enter a number. Please enter a number. And I'm going to just put a greater than there because that's where I want them to type. That's my new affectation. I've decided that way if I want to display some input, tell them where to type, I'm going to put that there. And so then I'm going to declare a variable, int x, and I'm going to read into it, cin arrow arrow x. And that will blow up if they type in a non-string value. Excuse me, a non-numeric value. It won't be able to be converted to an int. Or even if they type in like 3.0 or something like that. We saw, in contrast to what the test said, that you can get it into an error state where it will not accept 3.14 and then store the 3 into an int. So I think in the future I just need to remove that as a test question because it sometimes works, but it sometimes doesn't. And specifically it works if you initialize it. And that's crazy behavior for it to behave differently based on whether it's initialized or not. Okay. So if I was going to run this, let's repeat that. Cout arrow arrow, enter another angle brace. And let's read that one into a variable called y. So int y, cin arrow arrow y. And then we could just print them out, right? Cout arrow arrow x arrow arrow followed by quote space quote followed by arrow arrow y followed by endl. Just so that we see that it worked, that we see that our input actually had some effect in the universe. Please enter a number. Let me increase the font size. All right. 100. Enter another one, 200, and it printed out 100 and 200. But if I run it again and I give it bad input, like a 1.1, it goofed. Right? It didn't give me a chance to type in the next number. It did store the 1 into the first variable, but the second one was left in the buffer and wiped it out. Wiped out y. And so we can do that business with the CIN and putting it inside an if statement and calling CIN.clear and stuff like that. But rather than having to do that every single time I do that, I want to make a function that handles that for me. So my function is going to be called get CIN int because it's supposed to read in an integer. Get CIN int parentheses in parentheses. So we need to declare a variable, maybe R for return value or RET. And I'm going to make it loop until we get good input. So bool OK equals false. And then we're going to do while parentheses exclamation mark OK. While not OK. That's the same thing as writing this. While OK equals false. We're going to set OK equal to true when we're ready to exit the loop. Now this is considered a more professional way of writing that. While not OK. All right. Let's get our input. If parentheses, exclamation mark, parentheses, CIN arrow arrow RET, 2 close parentheses. If that failed, we want to display a message and we want to clear the output. Cout arrow arrow invalid input, please enter an int. Period or \n. And then we need to clear our input buffer, so cin.clear, parentheses in parentheses, and then cin.ignore, 1,000 or 10,000 or whatever, comma, single quote, apostrophe, \n, and another single quote, and then a semicolon. But if we didn't get into that state, then all is well. So we will set else okay equals true, semicolon. And now down in main, I'm going to call it. So forgive me for scrolling down here. I'm not going to put all this on the same screen at the same time, and the answer is probably I can't. I'm going to condense this a little bit by removing some of the white space. Makes it a little bit more difficult to read. All right, so instead of CIN arrow arrow X, I'm going to do this. Oh, I forgot one last statement here. This function needs to return the value that they just typed in. So the last thing in get CIN INT is going to be return RET. That's before the last closing curly brace of that function. So I just added that. Now down here where I have CIN arrow arrow X, I'm replacing that with X equals get capital CIN, capital INT, parentheses in parentheses, semicolon, like that. Please enter a number. First, I'm going to make sure it works. 5 and 6. Okay, and it printed out 5, 6. I'm going to run it again now, and I'm going to enter garbage. Invalid input. Please enter an int. Well, what if I don't want it? No. Right? Finally, I give up and typed in some good input. And it printed out 10 and 1. So it made this input function far more error-proof. It's not going to crash if they type in something invalid. It's not going to make the next input statement be skipped. I'm going to need to replace this int y with a similar call. So down here, y is equal to get CIN INT, parentheses in parentheses. And you could write another one of these for doubles. It would just have to be declared of type double here. And we would have to declare our variable int ret as a double instead. It would work just as well. Now what about that state where if we type in 3.1 when we really just wanted a 3 or something? I'm curious as to how it's going to handle that. There were build errors. Oh. My mistake. I put that in the wrong place. I should not have commented out the variable declaration. Instead, I should have commented out the place where we read into y. And then I better do a walkabout and make sure everybody's where I am. Get CIN INT, parentheses in parentheses. All right, like that. All right, what happens if I type in 3.1 rather than 3? Invalid input. Please enter an int. All righty, it didn't quite do what I really wanted it to do. What do I mean by that? It went ahead and kept that 0.1 as input for the next one to generate an error. So I'm going to fix that by calling one more dot clear. I'm going to change this else okay statement. It's going to look like this. Sorry, let me just edit it rather than reading it out loud. And then I'll highlight what I did. I wonder if that'll do it. That's probably not going to do it. Tell you what. Complete revision time. I deleted everything. Sorry about that, but that's easier than making y'all follow along with me. So delete everything between the while okay and the return. Here's what we're going to do. Open curly brace. I need to delete that closed curly brace because that's a problem. No, it's not. It would have been okay. if CIN arrow arrow RET okay equals okay equals true, semicolon. Else, we're going to print out our error message. Else cout arrow arrow quote not a number. Please enter an int. Closing angle end quote semicolon. And I'm going to just call cin.clear and cin.ignore as a matter of course. So cin.clear parentheses in parentheses semicolon, cin.ignore parentheses 1000. That's not a magic number. 1 probably would have worked. 10. We just want to make sure that as much as could reasonably be expected for somebody to type in and more, if somebody was trying to break our program, that we're handling that. 1000 comma in single quote or apostrophe backslash n closing quote parentheses like that. Bless you. So there's our new version of the function. What I'm trying to get it to do now is that if they wanted to type in a 3, but they actually typed in a 3.0, that it wouldn't crash. And it's working. It's rounding it down to a full int, but it is working. So we have written a function, a safe inputs function, that does this correctly. It gets an integer from the CIN input stream. Now that sure is a lot of work to go to. I don't appreciate that C++ makes us go to that much effort in order to validate our input. In the Java language, when we use a scanner, there are functions like hasNextInt, where we could ask, yo, do you have an int for me? And if it doesn't, then we could read it in, ignore it, and then ask them to do it again. And the syntax to me looks a little bit cleaner than that, but maybe that's because my most recent job was doing more Java programming than C++.
Can you scroll down to the bottom, please?
Yep. If you wanted to make a version of this that worked for doubles as well, you could just copy the whole thing and change the word int to double and everywhere you see it. Right there, right there, right there. Right? So I could copy it and paste it. Copy. Paste. And in this version, I would change that to a double so it returns a double. I would change that to a double just so it has a better name. And I would change the return type of the variable declared as a double. And that works. Now we could read in a double the same way that we were reading in an int down here, right? So if y had been declared as a double, then I would call get CIN double right there. I could still call get CIN int, but then it would return an int, so anything fractional they typed would be lost anyways. So the second number is supposed to be able to support decimal points now. What if I type in garbage? Not a number. Well, it shouldn't say please enter an int. That's one of the things I needed to change when I copied and pasted. I said there were 3 things I should have. Inside get CIN double, we changed that to double. We changed that word to double. We changed that word to double. And let's just make this, instead of saying please enter an int, let's change it to just a numeric value. It's fascinating to me that it accepted the 34 and then ignored the DSAF. I find that really interesting. You're going, I don't. I wish you'd talk about something else. Yep, it is ignoring all the garbage input. That's kind of neat. I kind of like that. All right, enough about that. Does anybody need me to scroll up and down so you can finish typing this, or can we move to another topic? All good? All right. So we have used some functions here, right? We used getCin int, and we used one called getCin double. I'm going to create a new function just to play with. Void add to. Not void though, because it needs to return a value. Int space add to parentheses int x comma int y in parentheses, and now this function is going to take those two numbers and it's going to return the sum of them. So return x plus y. That's all it needs to do.
I don't know why I put my finger there.
Okay.
Oh wait, yeah.
Well, we haven't finished typing it, so add the open curly brace and the closed curly brace and return x plus y. So life's a little more. You never know. Whoopsie. And so we could call that function, right? Int result equals add to parentheses 10 comma 20 in parentheses. And let's do a system pause there just because system, you know what I'd really rather do? I'm not going to really rather do anything. System parentheses quote pause end quote in parentheses. That's just so that when I run it, it doesn't run all the rest of that stuff, which would confuse me after too long. Okay, great. Yeah, so I should always stop it from running, you know, instead of hitting enter, so I don't have to do the rest of the input. That's the reason I've structured it like that. Now let's write another function called mult2, or add3. int add 3, parentheses int x, comma int y, comma int z, end parentheses, and it's just going to be return, I forgot a space there, int space z, return x plus y plus z. And so now we're going to say result equals add 3, and we're going to take that result, pass it in, and we're going to add in another 10 and another 20. So that really ought to kind of double it. And let's display some kind of output so that we know it's actually working. Cout arrow arrow quote result equals space end quote arrow arrow result arrow arrow end deal. So that we can see that. All right, and the result is 60 as I was expecting. So why is it equal 60? Because this function, we're passing in 10 and 20. Our arguments are 10 and 20, so the parameters get filled in. The parameter variables get filled in with 10 and 20, and it returns those added together, which is 30, which gets stored in result. And then we call add 3, and result is the first argument, so x is equal to 30, and y is equal to 10, and z is equal to 20, and it adds all three of those. 30 plus 10 plus 20 is 60, and that's what gets copied back there. And then it printed that out as a result. What if these were somewhere else? What if these had been copied, cut and pasted to the bottom of our code rather than the top? You don't necessarily have to do this, but if you want to demonstrate the point, take all that code, right click, cut it, and scroll down and paste it at the very bottom of the code, underneath the very bottom curly brace. Now Java doesn't care what order you declare your functions, but C++ does. When I try to compile it now, it's going to give me errors. There were build errors. By the way, we never want to run it and run the last build. So I'm going to choose do not show this error again and say no. I don't want to see that message. I just want it to tell me it didn't work. All right, maybe it'll work. Okay, so how do we fix that? What is the error? If I scroll the error list, I will see add to, identifier not found. It doesn't know what the add to function is. I have to declare the add to function with what's known as a prototype. So here, where was main? All right. Where that function was, or somewhere near up at the top of the code or something like that, underneath our # includes, int add to parentheses int, int, close parentheses, close semicolon. Wait, add to only took 2 parameters. Sorry, so I need to backspace over one of those ints. Add 3 took 3 arguments. Add 3, int, int, int. Now it'll compile and run. So if I do a rebuild solution, shouldn't be any errors. And then I should be able to run it, and it'll behave the same way it did before. So what does this line do? It warns the compiler that, oh, somewhere out in our project, there is a function called add2, which takes 2 integers. Remember, it was int x and int y. Returns an integer. And, oh, it's defined somewhere else, but just pretend like it's there. So now the compiler knows, okay, it's okay to use that function. That function takes 2 integers and it returns 1, so I know what kind of code to build. What if those functions were gone completely? What if I cut them out completely? I'm not going to cut them out, though. I'm going to comment them out. You don't need to do this yet. I'm going to comment them out so that they're not even in the project at all. So if I compile this file now, rebuild solution, I'm going to get an error, or at least I better, because the program can't work anymore. Those functions don't exist in the project. And here's our error. Looks pretty Greek. Unresolved external symbol, unresolved because it doesn't exist on our project. Int cdecal, cdecal means a C function, add to parentheses int, int. So we're seeing that it needs a function called add to that takes 2 integers and returns an int, and it didn't find it anywhere in the project. So I'm going to make a new CPP file that has those functions. Yes, sir. All right. I'm going to do the next step and then I'll come back. So I need to add a new CPP. Go ahead and delete those completely if you want. Nuke those because we're going to put them in a different CPP file. So I need I closed my Solution Explorer. So I need to open it back up. View, Solution Explorer, and where we normally add a file, I'm going to add a new source file. Add new item, and I'm going to call it adder.cpp or something, right? Because there are some add functions in it. And now I'm just going to put those functions that I deleted from the other one. Int add to, I could have copied and pasted, int x, int y, return x plus y, int add 3, int x, int y, return x plus y plus z, and I see something being underlined there and I don't know why. Hopefully it'll show up when I build it. Z is undeclared. Okay, that's true because although it was called add 3, I only made int x, int y, int z. See, I should have just cut and pasted. All right. So we move those functions into a different file. Why would you do that? You do stuff like that so that you could share that file with somebody else or to organize your code. You know, if you have one CPP file and it's got 2,000 lines of code in it, it's going to boggle anybody who looks at it later, including you. You try to break your code up into logically related groups of functions. So I have some math functions in a module called adder, adder, and I might want to put some file IO functions, you know, in a different CPP file. And it's up to what's known as the linker to fix it, right? Because they're in a separate file. So when it compiles LectureQ, it builds a file and it has those references to the functions, but it doesn't have the functions inside it. And then it compiles adder.cpp, which makes another object file, which does have the functions. And the last thing the compiler does is call a linker, which links those two object files together so that add2 and add3 are now available to the lectureq.cpp file. Alrighty, so cool. We have our functions defined in a separate CPP file. But that means that if we gave somebody else, if I gave Simon this CPP file and I wanted him to use it, he'd have to go and either copy these functions out and put them in his own code, which is a no-no. I want him to use my functions. Or he'd have to declare those prototypes. He'd have to go and add these to his code in order to get it to compile. Right? Just because I have those functions existing in another one doesn't mean it won't work without the prototypes. I'm going to get an error. It has no idea what add2 is, whatever add3 is. I'm going to put those back. So the prototypes kind of predefine the function. The word predefine sounds stupid, but it lets the compiler know that this add function takes two parameters and returns an int. And it needs that in order to build this, to build the code. But I don't want to have to add those two things to every project, right? Because what if I had 1,000 different functions in my adder.cpp, right? I could have a whole bunch of math functions. What if I had 20? I wouldn't want to have to type in 20 prototypes. So what I do is I create a header file that's got my prototypes. So go up above main, find wherever you declared your prototypes, if you did, right-click and cut them, and we're going to make a header file. So in the same directory where we've been creating our CPP files, I'm going to go to source file, right-click, add, new item, and instead of being a CPP, we're going to add a header. And I'm going to call it adder.h because our CPP file is called adder.cpp, so why not? Adder.h. And I'm going to paste those guys. It says pragma once, just leave that. We'll talk about what that means at another point. It's harmless, and not only is it harmless, it's exceptionally useful under certain circumstances. So since it added it, I'm willing to leave it there. All right, it's not fixed yet. If I run it, I'm going to get the same error. Add2 not found, add3 not found. The reason why is because lectureq.cpp still doesn't have any idea of what add2 and add3 are. But we can fix that. We have these #include statements up here. We're going to add one. We want to include our own header file. #include, but we're not going to use the angle braces. #include, double quote, adder.h, end quote. Why do we use the double quotes instead of the angles? The angles tells the C++ compiler to go and search the search path for that library. Microsoft has all these header files in some other directory, not in our directory, right? But we put this in our directory rather than the Microsoft CPP header file search path. And so we're saying, no, we want to open in this file, in this directory. And so that's what the quotes mean, is don't go looking for that file. Use it right here. Yes, sir.
Well, why don't you use that, or why don't you also use that for adder.cpp?
Because we didn't have a #include.
Why do we have to have a #include for the adder?
Yeah, why do we? Because what does pound sign include actually do? It runs out, it grabs the contents of this file, and it pastes it in right here for the compilation project. It replaces that with that. So what it's effectively doing is it's saying, okay, when we build it, it takes those 2 lines of code and then replaces that with that. I don't really want to bring in the CPP file in the same way. In this particular case, it might work. If I did pound sign include adder.cpp, it would kind of work, but it would kind of wouldn't, because we'd get a compilation error saying that those things were already defined. Let's prove that to ourselves. I'm going to do a pound sign include quote adder.cpp. It's going to compile okay, but then we get some errors. It says already defined. And the reason why is because it's defined in that header file, and then we're kind of copying and pasting it so it appears in this CPP file as well. So your CPP files you don't put pound sign includes for. They just sit there in the source directory. The header files you do put pound sign includes for. So that's typically what you do. You put your functions in CPP files, and you put your function prototypes in header files. And that way, I could give you adder.cpp and adder.h, and if you were going to ever use it, all you would have to do is do pound sign include adder.h, and you're ready to use my functions. For those of y'all who use Java, that probably seems like a little bit too much work, but that's because Java was invented 20 years after C++, so they made it a little bit easier to use. All right, anybody getting syntax errors now that they wish would work before we go on to the next topic?
Can I see at the dot X
Which one do you need to see?
at the dot X?
Adder.h?
Yes.
Okay.
Yeah, the pound sign include are not like
All right, definitely delete that line. And the one above it's probably just got too many D's in it.
that. 2D.
You spelled it with 2 D's here, so it better be 2 D's there.
It is.
I
Oh,
see
wait,
3.
it's 3D.
Yep. Now save it and make sure that error goes away. Or just rebuild it or something. Cannot open file adder.h. Oh, we don't have adder.h over here.
Oh my god.
It disappeared. All right, so we're going to right click on source files and do no. Right click on the source files itself, not this .cpp. Right click on the folder. Yep. Add new item. Call it adder. Pick header file. Sorry. You type in the adder.h. And click add. And it has to have these lines, these prototypes in there. Okay, that's fine, but you're going to want to make it look exactly like this. So just put semicolons after the end parentheses. Semicolon.
Okay.
Yeah, put a semicolon there,
Yeah.
a semicolon there, and delete the stuff in the curly braces. Yeah. Exactly. And a semicolon at the end. That one as well. Right. Yep.
Could I see the adder.cpp stuff?
Sure. No problem. Now what we ought to do is everything that references adder.cpp should have that pound sign include, including adder.cpp. So adder.cpp really does need pound sign include quote adder.h as well. Just because there's no guarantee that the functions are all declared in the right order. If add3 called add2, but it didn't know where add2 was, or vice versa. So now we have a reasonably set up project. It's got more than one CPP file. You can stick dozens or hundreds of CPP files into your project. You just put them all in the source files directory. And to define the prototypes so that every one of them can, call every other one of them, then you would put those prototypes in the header files. And we will do that again. So if it didn't all sink in 100%, if it only sank in 50%, that's okay. Something else I want to talk about are structures. I'm going to go back to lectureq.cpp once, unless somebody tells me not to go past this. Do you still need this? Okay, just a second. What goes in adder.h looks a lot like this, except these lines end in semicolons and there's no bodies. I'll recreate it really fast. I'm just going to copy these two functions. Right click, copy, and I'm going to go back to adder.h and I'm going to paste them. This is how Rochelle did it, and it's a good way to do it. Put a semicolon there, put a semicolon there, and delete the stuff inside the body. Like that. And now we have perfectly good prototypes. What is different about my prototypes now for somebody who didn't use the copy paste? We have variable names. The variable names are optional, but I actually prefer them to be there. The book will probably show you not putting the variable names. But variable names are good, are useful information, right? What do I mean by this? That. Don't type this. I'm going to wind up deleting this. But what if I had something that looked like this? String get val, or, get, and all it had was another string there, and that was my entire prototype. I don't know what in the world it's supposed to be trying to do. But if I had a variable name, get, and it had file name there, all of a sudden I know that this function has something to do with files, right? It's going to be opening a file. It's going to be getting the file. We have information. So variable names, parameter names are good information, and I like to include them in my prototypes, even though it's not necessary, and even though the book probably, in fact, I'm sure that the book often shows not putting the variable names. That doesn't mean you have to go back in and add the variable names now if your program is already working. The quickest way to make a prototype is just to go and grab your function, paste it, cut out the body, and put a semicolon at the end, and then it's done. Or, don't copy the body in the first place.
Yeah.
Oh, sorry.
Can I see your copy?
Okay, let's work through them. One or more multiply defined. Scroll up to the very top of the error list. Okay, that's a link error. One more simple is found. Scroll up all the way up. Start scrolling down. And then we have add2, but you commented it out. That's good. Keep going. We have add3, but it's commented out. Oh, keep going. Keep showing me. Is there anything at the bottom? Let's do a rebuild. I'll go to build and do rebuild solution. slash in front of each one of those. Comment each one of those out. Try to build that solution. Just gonna build that solution. I don't know what's wrong. I'm very sorry. To make it correct, go ahead and go to adder.cpp, and in fact, I would put the program. But anyways, go to adder.h. Go back to adder.h and uncomment those changes we made. Quit Visual Studio and go back into Visual Studio. There. And if it doesn't work now, I'm just going to say, let's just go on, because it doesn't actually have to work for you to have gotten the idea of us moving some code to another file and creating another file folder. I think maybe I know what's wrong. So go to File, click on File. That's the way. Go ahead and click it. So actually, that's the way. Show me the top of lecture view. CPP. So please. Okay, we have a pound sign include. Get rid of that one. Get rid of that line. We were talking about doing that, and it turned out to be the wrong thing to do. So get rid of that one. Get rid of that one, and now it's going to work beautifully. So I will reiterate that for everyone. Well, I mean, I guess it's thinking about it, but it didn't get a compilation there. So when we did that pound sign include adder.cpp, what that does is it actually brings in the contents of adder.cpp and pastes it into your program temporarily, so to speak. I mean, you know, it's not actually doing that, but it's bringing it in. And then when you try to build your project, you're going to get error messages about multiple objects defined. So when I demonstrated typing # include adder.cpp, that broke the code. And if you didn't catch me removing it, then that's why we got some problems. The specific error message is it's already defined, because now the code inside adder.cpp has been added to lectureq.cpp, but it already also exists in adder.cpp. So that was a mistake. Do not put that. If you see it in your code, delete it. All right. In the copious amount of time we have left, just not much, we're going to define what's known as a structure. A struct can hold multiple pieces of data, like this. CIN, nope, what am I doing? STRUCT, struct, patient, like that. Curly brace. And a patient has an age, int age, semicolon, and string name, semicolon. Then we're going to go down to main and we're going to create a couple of patients. Patient P1, semicolon, patient P2, semicolon, P1.name equals Bob, end quote, semicolon. P2.name equals Fred, end quote, semicolon. P1.age equals 13, and P2.age is equal to 16. So structure is a way of clustering multiple pieces of data in the same variable. This P1 variable actually has two pieces of data. It's got both an age variable and a name variable tucked away in it. So let's write out those two pieces of data that are tucked away inside patient 1. Cout, arrow, arrow, P1, and this is going to look weird, especially you Java programmers, arrow greater than age. Now I'm getting an error there. Maybe it was P1.age after all. Yep, it was. There goes my big talk. All right, P1.age, arrow, arrow, space, quote, arrow, arrow, P1.name, arrow, arrow, ENDL. And then copy that line and change the P1s to P2s. Now each structure can have hundreds of variables inside it. A structure could contain another structure. It's a way of bundling a whole bunch of data so that you can give it a single name and then you could send that to a function or write it out to a file or whatever, and then getting it back together. Let's make sure it actually works. There, right? Bob and Fred. Bob was 13 years old. Fred is 16 years old. So since I had you go to the effort of typing all that stuff, delete it. Delete those two lines. And we're going to move them into a function right here called void print P for print patient. And it's going to take a patient, capital P, and this will be the last thing we do because we're running out of time. Patient P, like that. And an open brace and closed brace, and now the code is going to look very similar. Cout, arrow, arrow, P dot name, arrow, arrow, quote, space, quote, arrow, arrow, P dot age, arrow, arrow, ENDL. And so down here, just call print capital P parentheses P1, and then print capital P, print P capital P2, like that. So we were able to move both the age and the name of patient 1 into this function with a single argument, with a single parameter, right? We did not have to pass them in separately. We did not have to say print P, age, comma, name. Instead, we use one variable to pass in two pieces of information, the name and the age. So up until now, we've always just had one set of data in our program, right? Please enter your age. Please enter your, your daily athletic levels. Please enter your height, your weight, right? And it only held all of that information for one person, right? My height, my age, my weight, so that it could calculate, my basal metabolic rate or whatever. Instead, we could make a record, a structure that had all that information. We need to know our height and our weight and our age. We could put all of that in our activity level. We could put all of that in a structure. And then we could pass that structure around as though it were one variable. Later on, we're going to do the same thing with something known as classes. Classes are the structures that are precursor to classes. They existed before classes. A class is essentially a structure that has functions inside it as well. If you don't get that yet, that's okay. I'm giving y'all a sneak preview of something that we're going to hit later when we start talking about classes. So I wanted to tingle your memory when we hit it again. Let's create our Dropbox.
That's too bright.
Sorry. Yeah.
Oh, by the way, I sent you my sphere assignment a long time ago, like March 20th, and I never looked at that.
Okay. Did you upload it into the Dropbox or did you mail it?
I mailed it to you because I couldn't.
Oh,
I
I'm
even
sorry.
I couldn't find a submission folder.
Okay. Hopefully there's a submission folder now, so if you can
Yeah.
find it, go ahead and upload it, please. And I apologize for not doing that right.
You can- Is it the 8 sphere density revised folder or?
Yeah, that's the most recent homework we've done, except now we're adding a new one, which is to turn that last one into switch case. But I don't think there's a folder for it yet. There will be soon. All right, there's now a lecture queue. Upload whatever you want to in it. You can give me the header file and the 2 CPP files if you want.
Can I see your code, please?
Yeah, sure. Which piece of the code? The last stuff we
What-
typed, this one? Do you need to see the structure itself or that part of the code?
Yes. I've got multiple errors. Trying to figure this out.
All right. Let me stop the recording.